Students, till last lecture we all had discussed about the safety measures. I told you that this is the unit in which we all are going to learn three things. First is the safety into the laboratory. That part we had already dealt with. Then second part of this particular unit is units of measurement. And lastly, we all will going to talk about the biostat. So let us begin the next part of this unit, that is units of measurement. So see, when we talk about units, so this gives us idea that we are specifically related to counting. So where do we require measurement? When we want to know our weight, we can measure our weight, reading watch, then body temperature, environmental temperature, whether it is hot, cold, then weighing a cantaloupe or anything. So what kind of measurements you have done today? You just make a note that yes, today I measure this. I counted money. I did this. I did that. So just keep an eye whatever things you are measuring. So generally, this all tools we use for the measurement. If you want to measure some volume, so definitely you are going to use something which can measure the liquid. Suppose you are preparing a cake, so definitely you are going to use certain type of cup. You are measuring some water into the laboratory. You are going to make use of the measuring cylinder, then watch, thermometer, then weigh scale. Now, for measurement, everyone was having the different type of way. Means there was no sophisticated system for measuring the things. So people, how they used to measure? They used to measure the 1 feet with the help of their hand, and they used to measure land with the footstep. So there was a need to globalize the thing. So they tried all they tried, and they make a perfect system that is called as the metric system, and they tried to make the uniformity into the measurement. So when they were metric system was designed, they kept many goals in their mind. So first goal was it should be universal and neutral. Now see, the thing is whatever I am counting. So you might have seen different type of the units also, yard, then feet, and all. So all these things were differing from region to region. So there was a need to make the things universal, and it should be neutral. So everyone can adopt it universally. Means a system, there was a need of a system which can be adopted. Now suppose if I am talking about 1 feet, so the olden people, they used to count 1 feet from their middle finger till their elbow. They used to count this way. Then when they want to count 1 meter, so one hand plus the shoulder distance. This way they used to count 1 meter. So these things cannot be means neutral. This can be vary from individual to individual. Footstep, if a person is very tall, will have the big footstep. If a person is short heighted, will have the small feet. So for that reason, for the neutral system has been designed. Now the system should be so perfect that any laboratory can be able to replicate this. Means the definition such as laboratory which equipped with the proper instrument should be able to make their own models for them. Means I want to measure the water. So the water, the original base unit is required. So base unit was the pure water and the median of the earth. At the median of the earth, whatever weight of a certain volume of pure water is there, it was considered as the base unit. So the base unit problem was solved, and decimal multiples was the another idea. Means all multiples and sub multiples of the base unit should be in the power to 10. We all are going to see the base unit powers also. What is the practical benefit of decimal system? Because decimalization makes the thing easier. So the British and Irish pound, or even the stock prices, when you will see into the stock exchange into the United States, you will find all these values are into the decimal multiples. Then there should be common prefix. It's not like that into the mass you have the different prefix, then volume different prefix, then you have the length different prefix. It will create lots of confusion, so there was a need of the common prefix. So they set certain common prefixes, like kilo means 10 is to 3, so it indicates the 1,000 times base unit. So the kilo, it could be the kilogram, it could be the kilometer, it could be the kiloliter. So it should be the common base unit. Then practical in use. The whole purpose for designing all such base unit was making it practical in the use. The base unit has to be close to the size of customary units which were then in use. So the meter being used now as close to the toys means there should be whatever base unit is designed. So it should be replaced with the existing units. So one example is given, that toys, which is the French yard. So one toys is equals to 1 meter. So they have replaced all this unit. So let us discuss the metric unit, that is also called as the SI unit. So first, for the kilometer to nanometer. See how to remember it, that it is starting kilo. Meter is the base unit. Okay, meter is the base unit. So if you want to measure the kilometer, so it is 1,000 meter. This is important to remember, because in the practical exam you will be given one unit and you will be asked to convert it into the different unit. So how to convert it practically, I am going to show you into the another video. So 1 meter is equals to 1 kilometer is equals to 1,000. How you all are going to read it? 1 kilometer is equals to 1,000 meter, or you can say 10 as to 3 meter. Then meter is the base unit. Then centimeter is the lesser power. So how many 1 centimeter is equals to 10 as to minus 2. 10 as to minus 2, that means 0.001. You can also say 1 by 100. Then millimeter, 1 millimeter is equals to 10 as to minus 3 meter. When we talk about the micrometer, 10 as to minus 6. Nanometer, 10 as to minus 9. Then we have also extended it picometer, femtometer, but it is not there included in your syllabus. Same way, in the case of the unit of mass, only the thing is, here we are going to use the base unit gram. In the length, we have used the base unit as the meter. So here we are going to use the base unit as the gram. So 1 gram will be our base unit. So when we talk about the metric ton, so it is equals to 1 into 10 as to 6 gram. Okay, kilogram, I told you kilo is the common prefix for 10 as to 3 base unit. So here base unit is gram, so 10 as to 3 gram. Then when we talk about milli, so milli is again the common prefix for 10 as to minus 3, then base unit, that is gram. So 1 milligram will be equal to 1 into 10 as to minus 3 gram. Micro, again 10 as to minus 6. So how you are going to remember? The metric ton is 10 as to 6, kilo 10 as to 3, then the base unit, then milli 10 as to minus 3, micro 10 as to minus 6, nano 10 as to minus 9. We should remember it, because lots of conversion we all are going to do practically when we all are going to perform our practical. So kilo 10 as to 3, milli 10 as to minus 3, kilo, milli, micro, nano. This way you all are going to remember. then 10 has to 3, 10 has to minus 3, 10 has to minus 6, 10 has to minus 9. So this will become easy for you to remember it forever. Then milligram, 1 into 10 has to minus 3 gram. Microgram, 1 into 10 has to minus 6 gram. Then nanogram, 1 into 10 has to minus 9 gram. Same way, the base unit in the volumetric conversion is the liter. So 1 liter is the base unit. So definitely kilo is 10 as to 3. So 1 kiloliter will be equals to 1, it is student 1 not 10. 1 into 10 as to 3. Then milliliter will be 10 s to minus 3, micro 10 s to minus 6. So this is about the base unit. Next lecture we all will be talking about the next unit, that is the temperature scale. So this is about SI unit. Then we all are also going to learn about the concentrations. Then not only this, we all are going to learn some practical units. So let let us stop for this particular point for this lecture.